All right, let's dive right in. We're going to peel back the curtain on the modern data and machine learning stack. Now, I know it looks like a crazy, complex beast from the outside, but stick with me. We're going to make sense of it all in just about 5 minutes. So let's kick things off with a question that honestly feels a little bit like magic. How in the world can a chatbot like ChatGPT give you a detailed answer about a private document, a PDF, a Word doc, that you know for a fact it has never, ever seen before? Well, it's not magic, but it is a really cool process. The secret is in a journey. It's a journey that takes raw, messy data and transforms it into real artificial intelligence. And this all happens inside what I like to call a digital factory. Let's take a tour. Okay, first stop on our factory tour. Every factory needs raw materials, right? For us, that starts right here, at the data conveyor belt. This is all about getting data from where it's created and onto our digital assembly line. You see, data is born all over the place. Imagine a customer makes a purchase. That sale gets recorded instantly in a transactional database, something like a Postgres. We call these OLTP systems, and they're built to run the business, fast and reliable. But to understand the business, to see trends, we need to analyze tons of data at once. And that happens in a totally different system, an analytical one, or OLAP. The whole challenge is getting the data from point A to point B. And that's where our conveyor belt comes in. It's a tool called Apache Kafka. But here's the thing. It's not just some simple pipe. It's more like a permanent, unchangeable log of every single thing that happens in the business. This makes it the central nervous system for our whole factory. Any machine, any application can just plug into the stream and get the data it needs without messing with anyone else. It's the ultimate decoupler. So how do we get the data onto this belt in real time? With a slick process called Change Data Capture, or CDC. It works like this. When that sale gets logged in the database, a tool like Debezium is watching. But it's not constantly asking the database, anything new? Anything new? No, that's too slow. Instead, it reads the database's own internal journal, its log. It sees the change the microsecond it happens, and bam, puts that event right onto our Kafka conveyor belt, all ready for the next stop. All right, our data is officially flowing. Now let's head over to the main floor, where the heavy lifting gets done. This is the analytics powerhouse, the place where we store and process all this information. It used to be you had to make a tough choice. You could have a data lake, which was super cheap for storage but kind of a mess, or a data warehouse, which was organized and reliable but cost a fortune. Well, not anymore. Today, we have the lakehouse, and it's the best of both worlds. It uses these cool new open table formats like Apache Iceberg to give you all the reliability of a database. I'm talking ACID transactions, but it does it right on top of that same cheap cloud storage. This is a huge, huge deal. Now, to actually work with the data in our lakehouse, there are two giants that pretty much rule the space, Databricks and Snowflake. Here's how to think about them. Databricks, which is built on Spark, is like the all-in-one Swiss Army knife. It's got tools for data engineering, data science, machine learning, the whole shebang. Snowflake, on the other hand, is more like a perfectly tuned, high-performance race car. It's a managed SQL warehouse that's just ridiculously easy to use and focuses on making analytics incredibly fast. So, it's the all-in-one toolkit versus the specialized, high-powered appliance. Okay, our factory is looking pretty impressive. We've got a conveyor belt for data, we've got a processing core, but with all these powerful machines running at once, it could get real chaotic real fast. What we need is a factory manager to keep everything humming along in perfect harmony. And this is a super critical question, right? You have data zipping around, getting stored, getting transformed. Who's in charge? Who makes sure that step 2 doesn't start before step 1 is finished? And what happens if a machine breaks down? Who tells it to try again? Well, that's the job of an orchestrator. On one side, you've got the legend Apache Airflow. It's the battle-tested veteran, it's got a huge community, tons of integrations, and it's rock solid for those predictable, scheduled jobs. But on the other side, you've got these modern Python-native tools like Prefect and Dagster. They're built with the developer in mind, they're super flexible, and let you build complex data flows that feel just like writing normal Python code. And here we are. We've finally reached the most exciting part of the factory floor. This is the intelligence layer. This is where all that clean process data we've worked so hard on gets turned into actual, useful AI. The secret sauce here is something called vector embeddings. It's a way to take anything, a word, a sentence, an image, and turn it into a string of numbers, a vector. Just think of it like this. We're giving every single piece of data a unique address, a coordinate on a giant multidimensional map. And on this map, things with similar meanings, like the words king and queen, end up as neighbors, located really close to each other.
And this takes us right back to our very first question. The technique is called Retrieval Augmented Generation, or RAG. Here's the trick. When you ask a question, we first turn your question into a vector. Then we search our giant map, that vector database, to find the chunks of your private document that are the closest neighbors to your question's vector. Finally, we take those few relevant chunks, hand them to a large language model, and say, hey, using only this context I just gave you, answer the user's question. The model never needed to read the whole document. It's just using the cheat sheet we gave it. Genius!
So where do you build this incredible map? Well, you've got great options for every flavor. If you want something that's just easy and works out of the box, there's Pinecone, a managed cloud service. If you want to add these superpowers to a database you already have, pgvector is an amazing extension for Postgres. And if you need just raw, blistering speed, you can use Face, which is the C++ library from Meta that actually powers many of the other tools. Wow, what a tour! We've gone through the entire factory, from raw material to finished intelligence. So let's take a step back and look at the blueprint, a clear roadmap you can use to navigate this whole world. Here is your 4-step playbook for the modern data journey. Stage 1, you stream your data in real time with something like Kafka. Stage 2, you store and process that data in a lakehouse using an engine like Spark or Snowflake. Stage 3, you orchestrate all those moving parts with a manager like Airflow or Prefect. And finally, Stage 4, you build the intelligence layer using vector databases and RAG to create some amazing AI. So there you have it. We've just designed a complete digital factory, one that can take raw data and turn it into real intelligence that can answer a question about a document it's never seen. We've built the factory. The only question left is, what are you going to build with it?